was going to have like just interactive stuff that is internally.
Broadcast is live.
Okay.
So you know it's live recording.
It's a party, me and Becky.
We have our delicious Saturday night beverages.
Yeah, we'll see you
Drinking our spritzy water and kombucha.
Spritzy tea and spritzy water.
Yeah, that is like super bubbly.
Maybe Phil shook it.
No.
Okay. I did not check it.
It could have, the longer it sits at room temperature, the more bubbles it makes.
Hey Scott, how's it going?
I mean, from the
Good.
We'll get going in
like
just a few.
No problem.
I like it.
You're coming in loud and clear, that's good.
I like how he has like a little like introductory trailer.
What are you running in front of your, what are you running in addition to your webcam so you can do the tiling?
Cam Twist, which is a free software.
Yeah, and so that's the Windows...
Mac version.
It's the Mac version, and you can put little tiles and stuff all over it.
Yeah, and then you can do the cutting between cameras and
that's nice.
have different kinds of titles.
Pro.
They're if they can do a few more things, we could actually maybe do Ask an Engineer using Google Hangouts one day. But I still need like a full-featured Ustream Pro software.
Camcast isn't as fully as Ustream producer, but it's really useful.
Okay, we are full house here. Hello, is it Ian?
Yes, it is.
Hello, Ian. We're gonna call on everybody. We're just gonna give everyone a few more seconds to get into the room here. Hey, Steven, how's it going? Hello.
Steve's working on his computer.
Yeah. All right. Just give everyone like 30 more seconds, and then they'll probably come in a little bit. All right.
I got my demo stuff. You
got lots of stuff ready to go. All right, we'll start this up. Okay, if everyone can mute your mics, we'll call on you. This is the show and tell.
Yay, show and tell!
Want to say hello?
Hello, everybody. Welcome to an exciting show and tell. I'm Lady Ada, and this is Becky, and
hello.
this is AdaBot.
Hello.
And basically, we do the show and tell every Saturday at 9:30 before Ask Engineer.
Yeah.
And pretty simple show with something to tell about. If you're not showing something, mute your mic. So otherwise, we like really icky feedback loops, and it basically kind of takes down the entire thing. We'll call you in the order that you came into the chat, pretty much.
Yeah,
so yeah, just be ready to.
Okay.
Something cool.
First up, Scott.
Scott.
Hello, Scott. How are you?
Howdy.
I see LEDs doing something over there.
Yeah.
Yeah.
So,
either that or your skin changing color.
Or you're a
on its own.
So what I made is a little holiday light display. And so this is my LEDs with one of the large LED strips and also the pixels. So there's 2 strands of pixels and one 5-meter length of LED lights.
Oh, yeah.
And then
ready ahead of time.
Yes, and so I'm going to...
Days of the holidays.
So I'm going to kill this. And so I made a little box and I appropriately labeled it.
Good work.
And use some nice connectors that I'll...
JST connectors.
Yes.
I like them. You know, when I was in school, we had to like hand make cables, and we could never find good wire-to-wire cables. I'm so glad that you can get cables so easily now, because I see how easy it was to like disconnect.
Hey, look, there's some perma-proto action, I think.
There's a.
All right. So I'm just taking it out of the box here that I made. I actually soldered in a couple extra connectors there to make it all nice and easy. And we have a perma-proto board here, and a small Arduino compatible, and it's all soldered in to this nice perma board. And I tried to make it as small as possible.
It's pretty small.
And put in an extra jack onto the rails here, so I got the power. And the only thing I added was some little heat sinks to the 3 little transistors there.
Yeah. You really need heat sinks? I'm surprised. Like
not at all.
Okay. No, it's cool. It's like I don't know which transistors or FETs are using, but we have FETs in the store that are so low RDS on, they can basically supply like 30 amps before they get warm, which is awesome.
Yeah, these are the FETs from the store, the
Yeah,
N channels.
It's totally cool that you added the heat sinks, but
It looks really
The
cool.
next version will be water cooled.
Oil cooled.
Yeah.
I think if you were getting up to like 100 meters of LED, maybe you'd need it. But when it's just an enclosure, it's always good to have some heat sinks.
You could use the new waterproof cables.
If you was doing something outside.
Outdoor Christmas tree.
And where did you pick up that little project case?
We have a little store locally here in the Bay Area.
That's cool.
Yeah.
Like the last store.
Yeah, we haven't kind of decided on a universal project case. You have the Arduino ones, but maybe we'll.
It's tough.
Yeah.
Is it a Hammond case, or a Bud case, or any brand? It's like an ABS case, right? You just machined it pretty easily.
Yeah, it's Serpac, S-E-R-P-A-C.
I remember Fry's.
It's written in there.
Years on it had some really cool enclosures.
Okay.
It's tough because you have to kind of have
Well,
all of them.
Cool project. Just so everybody knows, Scott worked on the necklace that Becky's wearing right now.
Oh, cool.
You gave this necklace more life. Battery life.
More like. All right, good work.
Excellent.
All right,
So this
thanks.
is for your Christmas holidays, or what? Will you?
This is just decorating my office, so I actually
Oh.
string them all around, and I changed the LED pattern depending on what kind of holidays, like St. Patrick's. It's
Oh, that's
white.
Oh, St.
Yeah.
Patrick's Day is next weekend, so he's not too
And then there's
early.
Easter, and you can do the
Wow,
pastel.
yeah.
Yes.
You're all set.
Once in a while, I have to come up with predictions for article. I predict Hallmark will be the largest distributor of LEDs one day. Yeah. Anyways,
Okay.
I don't know.
Cool.
Okay.
All right, nice work, Scott.
Dang.
All right, thanks.
All right, Scott. Okay, next up, Ian. Hello. Show us your project. Unmute your mic and show us what you got.
Hey guys.
Hello.
So about 6 months ago now, Lemore posted the Kickstarter project that my friend Kevin and I started to the blog, and we actually built this little thing, which is a 2-channel.
Hold on. Turn off your mic. Oh, wait.
Let's see. I think that was Michael, who just came in. Please mute your mic. Oh, keep going.
Sorry, Ian.
So yeah, it was it's a 2-channel USB source measure unit, and so it's essentially an analog multi-tool that lets your computer source or measure voltage or current
Oh,
a
that's
couple
right. I
dozen
remember
times a
this.
second.
That was a long time ago.
That was.
Wow.
So we spent a lot of that time down in the Skunk Works,
Okay.
and then we worked out the sort of supply chain issues that always present themselves at the worst possible moments.
You're like, I found the perfect chip. Wait, it's discontinued now. No!
Yeah, well, in this particular case, it was we found the perfect chip. They aren't selling them yet.
I don't know if Devices does that. So does Maxim. They're always like, check out this chip, and you're like, I'm excited, and they're like, coming soon, in 9 months.
Yeah.
Yeah, Atmel tried to tell us that the chip was we're using an X Mega processor on here,
Yeah.
and it went from availability or lead time of, I guess it was a month and a half to 3 months, and we were like, yeah, guys, that's not going to work.
The
So-
X Megas have a DAC on them. That's what you're using them for, or is it a high-speed ADC?
Actually, it's the high-speed ADC. We have to use an external SPI DAC, the MCP4922 that Dave Jones tore apart on the the Amp Hour podcast a while back.
Yeah, I used it on the Wave Shield a couple of years ago. It's actually a pretty nice, low-cost 12-bit DAC. I guess the 22 is probably a 2-channel, right?
Yeah, the 22 is 2-channel. We've been pretty pleased. And so the reason I'm actually showing and telling now is because we're finally putting the finishing touches on documentation. The hardware's stable. I actually wrote a Bodhi plot script that I'm going to show off a couple of plots of here.
Okay,
Let's check it out.
let's some plots.
Yeah, for those of you, all right, now I need to figure out how to do this. For those who aren't sort of analog hackers, Bodhi plots are a way of representing the frequency domain behavior of a system by showing off amplitude and phase change over time. And so, yeah, so I threw together a quick high-pass filter, just a 1-pole RC filter, with a 22 microfarad electrolytic capacitor and a 100-ohm resistor, and quickly discovered why you're not supposed to use electrolytic capacitors in audio signal processing.
Yeah.
The phase there is kind of wonky, and I'm pretty sure that's because, well, the capacitor has a fairly high ESR, and also, yeah,
That's right. They don't. They're actually electronics are kind of. They're really meant to be run at like 60 hertz and like maybe up to 100 or 200 hertz. Anything above that, you really want ceramics or like special capacitors. Film polyester films also work okay.
Okay. So yeah, it's been a fun project.
Yeah.
And I actually used it to charge a small 1-cell LiPo earlier today, just for lulz.
That works, yeah.
So it does constant current, constant voltage,
Or,
up to like half an amp or something?
Up to actually 200 milliamps. So we're playing nice with USB, and because you have 2 channels, and then you have some extra op amps that are on there that all have like quiescent currents. 2 channels at 200 milliamps, 0 to 5 volts, and I'm constantly plugging random stuff from my desk, which is a little on the messy side, into it, and either bogey sweeping or just actually curve tracing.
Yeah.
So it's been a fun project, and I went from being a pretty solid embedded guy without a clue in the world about how this whole analog the rest between 0 and 1 worked. And wound up learning a lot. So now I just need to figure out how to figure out current sense amplifiers, because one of the problems we've encountered is the chips labeled as current sense amplifiers are designed for people doing crazy high power stuff.
Yeah, they're for wall power.
Yeah,
That's
exactly.
What they're designed for, yeah.
And so if you're trying to toss around 40 amps, your precision requirements are a little bit a little bit different than when you're trying to toss around 200 milliamps precisely.
Well, if you have, you could do it a couple ways. You could do it with a low side current sense and just a really, really high precision rail-to-rail op amp. That's the kind of most common. You can actually also, there's a couple chips out there that do differential current sensing, so you can current sense high side or anywhere you want.
Right now we have a high side current sense amp made by Maxim.
Yeah.
And we're not particularly pleased with the linearity. They like a lot of rail-to-rail chips, they have a level shifter in there, where your your NP or where your NPN transistors switch over to a PNP, and so that's causing a big glitch. Well, a little glitch, but one that looks big when you have the gain turned all the way up and you're doing the wrong thing.
It is going to be tough doing it because you can't do if you do low side sensing, you risk people grounding.
Yeah,
you're earth grounded, so.
We made a very conscious decision early on not to do low side sensing.
Okay. All right. Becky, stop telling them to do low side current sensing. They made the decision. All right, cool. So you have how many people signed up for the Kickstarter project?
We actually had over 150 people buy the little boards, and that gave us enough money to do a couple 100-unit production run. Kevin and I spent about a week bolting together stuff. We have 2 pieces of acrylic and a PCB with spacers in there and nuts and little rubber feet. And
I like feet, circuits of feet.
We thought it was a good idea at the time, and then we spent all the time doing the whole fulfillment game and sitting down bolting stuff together, coming up with jigs. Yeah. The test fixture with pogo pins was the easiest part of the process, actually.
Yeah.
So.
No, it's the fulfillment is the tricky part.
One thing you can check out, I mean, you probably already have equipment, but like the Regal scope we have can be programmed through a computer. So if it's actually designed for doing analog test suites, which is actually something a little bit challenging to do. Like it's easy to design a test suite for digital stuff. It's harder when it's analog because it's a range that you're okay with.
So you can program it.
If you have a scope, if you have a scope, check out whether it has that capability, because a lot of oscilloscopes now, they do have test suite capabilities for this kind of thing, where you're like, tell me what the frequency range is, or what the impedance it can do.
And when you're in full production and you're selling these outside of the Kickstarter fulfillment thing, let us know. We'll do a follow-up post. It's a good story.
Okay, actually, we are now selling them now, or we're selling them now.
Okay.
All right.
Do up a post. You can email us or do up a response in the comments on Lamore's page, and we'll try to remember.
Fantastic.
All right.
Excellent. All right, moving
Cheerio.
along. Ethan, unmute your mic. Ethan is a star. He was in our badge program for 3D printing and for high altitude balloon stuff. How's it going?
Sweet.
I watched your TED Talk.
It's going good. I got your badges.
Woo! There we go. Yeah, you did a quadcopter. No, I'm sorry, not 3D printing. Quadcopter and.
Oh, okay.
Yeah. 3D printing.
Because he was on the. Yeah, I know. The next one you have to earn now is 3D printing because I said.
You did that. So what are you showing off tonight other than your badges?
My high altitude balloon project that I did last summer. So I saw Nathan's SparkFun, Nathan Seidel or Seidel, however you say it. He did a balloon project, and I was really excited by that when I saw it. So I wanted to do my own. And well, to get to the electronics, here's my very primitive board. But
Wow.
Okay.
so
Board.
it's the first circuit board I ever designed, and it's not very good now. But
Well, more
there's
stuff about all her designs too. She's like, I don't like this one.
Okay, so what's that? That's a GPS.
that's the GPS that we use. It's good to 100,000 feet, which is why we bought it.
Yeah.
And then I actually taken a lot of stuff off the board, but there's a BMP 085 pressure sensor that we use to verify the altitude.
Yeah.
I took that off for my quadcopter project.
You got
It's all
some points
from
out?
Cypress PSOC. My dad was the nerd programmer guy on this one, since I don't really know much about that.
That's a huge chip.
Yeah. Well, we're gonna control an InventSense one just to track the motion and stuff and play with that. And then there was air pressure and temperature and all this complicated stuff that never worked out in the end, of course.
And then you got the battery pack on the back. So that's the electronics that's gonna go inside. You have like a foam cooler thing, or what do you?
Yeah, I'll show it to you.
Yeah. And has this gone up yet, or are you gonna bring this up?
Yeah, it went up.
It went up.
last
Yeah,
year,
yeah.
and he gave
And
us
it came down.
Oh, okay.
They're awesome.
Yeah.
I wish that's so cool. Project to do with
He's
you.
So it
actually
went up to-
in the balloon right now. I don't know.
What actually happened was it went up to about 88,000 feet, and then the balloon popped, and then the parachute got caught in the balloon. So for about 40,000 feet, it just fell like a rock. But it somehow opened in time and then came back to Earth safely. And it actually landed right next to the road. So we just drove up to it and picked it up, and that was all fine.
That happens
Wow.
in NASA all the time. It's totally normal.
That's really cool.
Excellent.
Yeah, I'd like to do a project one day. We're trying to get these GPS modules that can do high altitude.
Yeah, we'll have some GPS modules soon that you'll probably want to check out.
For high altitude. We're getting them to take out the altitude restriction because it's actually, as long as it keeps the speed restriction, that's okay.
Mm-hmm.
So we're going to try to get some nice lightweight GPS modules.
Yeah, you can choose one. It either has to be high altitude or it can go over 5,000. 500 miles an hour. Something like that.
Yeah, what I found was that the MediaTek chipsets have both limits, and the Surf ones have both limits.
Yeah,
But the ones like Trimble don't have
them.
them.
Take it out. So we're actually like asking them, and they're like, "Oh yeah, we'll do that." So we're like, "Yay!" We have to like custom order them.
Yeah.
They don't do it by normally. So that's why like I'm really excited. Because otherwise, there's a couple of chipsets that don't, but they're much more expensive or hard to use.
Well, what's your next project, by the way? What are you working on next?
I'm still working on the quadcopter, which is my main project. I got the version 2 board in, and I started that, so see it.
Oh, cool.
It's a
Wow.
lot smaller than the other one.
Oh yeah.
Board.
As you work on this, go back on the show because this is a good one to check in with you.
Yeah. So this one I originally had 2 boards that had air pressure sensor and the InventSense gyro and accelerometer, and then this time I put it all on one board, and I went really kind of dangerously close to my soldering limits with all these little teeny.
Yeah.
Those are really hard to solder. Yeah, no. Do you use hot air or do you use a soldering iron?
The magnetometer is leadless, so I had to use hot air for that one. But
and
it worked. The connections are good as far as I can tell.
Good.
But the MPU one, I was able to go within a really fine tip and put little tiny bits of solder in, which wasn't that bad.
That's cool.
Well,
Actually, the hardest part was the...
That's why you can do it.
Yeah.
Yeah, and you don't really
Stay
have
away
to-
from caffeine because
Stay away from the espresso because it'll make you shake and then you can't solder very well anymore.
This doesn't make much sense, but I wanted to put a GPS on the back, so I have like a tiny little GPS waypoint following drone.
Yeah. Well, if you want
So
to
this is actually the hardest one to solder because the pads are cut in half on the side, and you have to solder them like vertically, almost,
Oh,
like
no.
on the side.
What is that?
And you
Is that
can't really
Trimble?
get your solder tip in there.
Yeah,
So,
the camera's not focused. Is that Trimble?
yeah, the Trimble ones are the ones, same one I use on here, but this is the new version.
Yeah.
Okay, cool.
Very cool.
That's
Well,
really
check in
cool.
as you keep working on that quadcopter. We want to see its progress.
Okay.
All right. Next up, Steven. Unmute your mic. Hello, Steven. How are you?
Nope, we can't hear you.
Nope. Your mic is not unmuted.
Hello. No.
No, can't hear you.
No.
Oh no, we can't hear Steven. Maybe you can mime it. Yeah.
Okay.
Oh no.
Well, it looks like he made it in
Yeah.
some sort of clock or oscilloscope
I
or
kinda like
something.
it. This has been
It's
happening
an
lately.
oscilloscope. It's a small oscilloscope. It's a purse-sized oscilloscope.
It's really fun. It's like charades. We've done
Yeah.
this a couple times now.
Okay,
It's
so you have a laptop oscilloscope from like the 60s or 70s or something. Those are really cute
Yeah.
and small. And you turn it into a clock.
It's one
Turn it
word.
into a clock? No.
It's a movie. It's a celebrity.
That is about the size of a bread box, though. He's going to show what he did with this oscilloscope. Those are really cute. So I've seen people take the tubes from those and they turn them into...
Okay,
yeah,
here it is.
these tubes are really cute.
Ooh,
And then you can see it's like all tube-based.
Yeah.
that's cute.
Yeah, and it's all like hand-wired. And there's a transformer. Don't touch the other side because it's like 1,000 volts, okay?
Yeah. That's it.
I hope it isn't plugged in.
Yeah.
Okay. And so you've got, these long tubes, and that's the electron scanning
That's really
tube.
cool.
Yeah, so it's really neat.
Oh, excellent.
So I think Riyad Wabi, who designed the original ice tube clock, he took one of those and he modified it and turned it into a clock, and it's on. It's a Heathkit.
Oh, it's a Heathkit. That's cool.
And so
Nice.
Woz had. Do you remember Woz's room? She had an oscilloscope clock
Yeah.
with the little hands
Yeah,
that
yeah.
rotated. So you should check out Riyad's website and just steal his code, and you should make that into an awesome clock.
All right. Looks
And
like
it
he's
looks
doing
like
something in there.
Internal. Yeah, so you can maybe pipe directly into there.
Yeah.
I don't know. This looks cool.
All right. Well, thank you so much, Steven.
That's a cool. Where'd you
And
get it? I don't know. Like eBay or something, or
He'll put it. He'll post a link.
I'll post a link. Okay.
Yeah. We don't even need words anymore. We're all like on the same wavelength.
That's cool. So somebody actually had to solder together
Yeah.
an incredibly dangerous oscilloscope.
Yeah.
All right. And
I love
last one of the
lawyers.
night. Michael, unmute your mic and show us your project.
Hey guys, I wasn't going to show tonight. Am I?
Yeah.
Yeah.
I'm unmuted, right?
Yep.
Yeah.
I wasn't going to show tonight because I'm exhausted. We had the first electronics flea market at De Anza here in California, and I help out. So I was there at 4 in the morning. So I'm going on 3 hours of sleep and a couple of naps after. But after I guess it's Scott,
That's what you picked up at the fair.
I didn't. I just picked up some batteries.
Oh, okay.
But after Scott talked about his, and you guys mentioned the Hammond case. I have a Hammond case I use for a project. I just want to show that.
Oh, yeah.
Okay.
So this is one of my APRS projects. So you can see it's one that had one of the sliding tops. I replaced it with acrylic.
Okay.
that's
Yeah.
nice.
And then one thing I'm proud of, even though it doesn't look the greatest, at the tech shop I used the Bridgeport and machined out the openings.
Nice.
Okay.
Nice.
This is a project I got done in about a month with the wiring, and I have if you look under M. Peckner, you'll find the Flickr stream of the pictures of the boards and everything inside of here because I did line up a couple of things.
I do like those extruded Hammond cases. They are really good looking. If
But if you need any mods, you have to have the right equipment.
and it's also you could slide. They have little ribs so you can slide in PCBs.
Right.
Is that what you did
You
with
can
that
put
on the
multiple
side?
PCBs
Yeah,
in.
so I've got two boards. The bottom board has a Arduino Pro mounted on it. Sitting on the side here, this loose thing is a TTL RS-232 converter because I needed to go between the Arduino and this TNC here.
Yeah.
And this is a APRS transmitter. So what goes here is a specialized cable that provides power to the open track, which supplies power to everything else, and the hookup to my handheld radio. And there's a connection for the keyboard.
Cool.
And the other thing.
Oh,
So there's one more statement I want to say. I did order the C, and I am truly waiting for more tutorials when I have time to get back to it because I got it. I don't understand analog electronics very well to have just jumped into the board, so I'm truly waiting for some tutorials to teach me.
So which product? Which product did you order?
Jumping in.
Yeah.
So for you, I actually spent today writing a tutorial, so I'll have that live in a bit.
Oh, I was confused. I was like, we don't have anything sold to C. What do you...
This is the future. This is the future of tech support. Hey, I bought something. Hey, is the tutorial done yet?
Yeah.
Okay,
nope.
I'll look at it later. Okay, great.
Working on it.
You actually, the best tutorial to learning analog is, and I tell people and they don't believe me, but if you get that Horse in the Hill student handbook,
which we sell,
and it's actually not available in bookstores or like.
It was so difficult to get these student handbooks.
Okay,
but the student handbook is the secret. You can get it, and if you don't have Horse in the Hill, it's okay because it has like 12 projects that you go through, and it teaches you it teaches you basically analog electronics. That's
Michael,
I have a group. It's called the Bay Area Radio Builders Club, and we're a group of ham radio guys trying to learn analog. And we went through the Forrest Mims book.
But not the student manual yet, right?
No. I'm not on Forrest Mims. I'm talking about the Horse and Hill student manual.
Yeah, we have them over there.
Forrest Mims, it's good, but it's not deep.
Yeah, actually,
it's a very
I will give
vocabulary lesson.
I'll give you one of these student manuals. I'll trade you something for it. We can make a deal right now over Google+.
Oh no, a deal!
We'll make a deal. If you come back on the show and show all the cool stuff that you get at this flea market, because you're going back tomorrow, right?
No, it's once a month, so it'll be the second Tuesday. It's once a month from March through October.
Okay, so I'll give you one ahead of time. All you have to do is the next time pick up some cool stuff or take photos and share them on a show and tell.
Take a video or photos of the event.
I will absolutely do that because you find stuff there. I'll point you to some guys that posted some pictures.
Yeah, you can be our embedded reporter, and I'll trade you a student manual for it.
You got it.
All right, what a deal.
Deal.
Wheeling and dealing. See, that's the future. This is the future of eBay, and that last thing was the future of tutorials.
Okay.
Okay. All right, everyone. We're going to set up for Ask an
Thank
Engineer.
you.
Oh, wait. Steven's back. Oh, look. He's got something.
He's got something.
Can you hear me?
Yeah!
Okay, cool. I'm going to talk about it, the oscilloscope.
Yeah.
I found it at a garage sale,
Wow.
and it was in the free bin because they didn't know what it was.
Oh, that's perfect.
And it has a bunch of issues like it has no way of actually telling what voltage it's reading, except for some grid lines on the that are unlabeled.
Yeah.
And but it's still cool, and it's not really linear when it reads.
Yeah.
Kind of got like a little bump in the middle.
I would totally make into a clock.
The Heathkit manuals are online somewhere, and there's someone who sells the old ones. I don't know if that would be helpful.
Do you know what? It's probably not. I mean, this is a really old school.
It might
probably
You
not.
got to get more help from you guys, right?
What was that?
On the forums?
Yeah, you could post up in our forums. There might be someone who knows about them.
We didn't design that kit, so it's going to be a little difficult.
But I've actually talked to the person who now owns the Heathkit manuals, which is a really weird long story. I can point you to it.
Okay.
And I bet there's some people online who have these running, and there's also a group of people that swap parts for these.
Okay.
So post up in the forums, and I'll post the things I know about it.
Sure.
Okay. I'm glad the mic worked out, too. Well, thank you so much.
So
and then, William, we only have a couple seconds or so, or minutes, but can you show us your project?
It's a laser thingy.
Are you there, William?
I think it's a laser thingy.
Yeah, I'm here. Hey, how's it going, guys?
We have about a minute and a half, but if you want to show this off, you can also come back next week, but whatever you're working on looks cool. We want to see it.
Yeah, sure. I guess I could explain it really fast and give you a quick demo. It's our...
Oh, you cut out there.
Uno?
Yep.
With the old...
Back.
Yeah, I'm still here. And this is a laser diode I made myself, and 4 DC motors. It's a pretty simple laser spirograph.
Laser spirograph. Okay, cool.
Yeah, I'm going to mute my mic and go dark, and I'll let it run some patterns for you real quick.
Oh, great.
Okay, great.
Okay, and we'll play the show out with this, and then we'll have to...
Play us out, laser diode.
Yeah, play us out, laser diode. It's exciting.
Oh, it's a purple laser.
Okay. No one look directly into your webcam. All right.
Oh my god, this is huge. Okay. You ready?
Here comes the party.
I actually don't know how this thing works. What is it?
So the motors spin, and
Yeah.
as they spin, they create different paths.
Web
Like,
cameras.
They have a little, like,
Web cameras love
Why, 'cause they have a little, like,
dark
wrist
rooms
on
lit.
the
Oh, look at this.
There's a little mirror, and the mirror rotates.
Oh, the mirror rotates. Okay.
That's super
oh,
cool.
Okay, yeah, that is really cool. Oh, it looks beautiful. Party.
That's super cool.
Yay!
Cool. Yay, thanks.
All right. Well,
All
thank
right.
you so much. Oh, that is really neat.
Woohoo.
All right.
Live inside of CERN. CERN called in this week. Look, you can see the Higgs particle. Okay.
Okay,
everybody.
bye,
We're gonna do Ask
everybody.
an Engineer exactly 10.
Bye, intelligent life form in space.
Hig, you don't look too fat at all. Your mass isn't too big. You can't tell Hig that. That's why.